Benvenuti! Welcome, everyone. Thank you for joining us for another incredible space flight. Today's flight is a special one. Not only is it Virgin Galactic's first commercial flight, our start of commercial service will carry a team of mission specialists and payloads from the Italian Air Force to space from Spaceport America, the home of Virgin Galactic in beautiful Sierra County, New Mexico. We are excited to take you on this journey with us and provide you with coverage of today's space flight. Hello, everyone, and ciao to all of our viewers in Italy today. I'm Sirisha Bandla, and I will be your host for today's flight, along with our Mission Insight Specialist, Jonathan Ritchie. Our Mission Insight Specialist is a new role, giving us live updates from our Mission Control Center, giving you, our viewer, an even more engaging experience. JR, what's up?
What an exciting day. It's a pleasure to be here in the studio with you. I'm excited for today's flight, and I'm looking forward to sharing this journey with all of our viewers across the globe.
Now, today's flight is in collaboration with the Italian Air Force and the National Research Council. The mission is called Virtute 1, both an acronym for Volo Italiano per la Ricerca e la Tecnologia Suborbitale, or Italian Flight for Suborbital Research and Technology, and the Latin word for virtue that is also in the Italian Air Force motto, Virtute Siderum Tenis, with virtue to the stars. Now, today's flight is already well underway. Our crew on board our spaceship Unity took off, made it to our mothership Eve at around 8:30 a.m. Today will be our 6th space flight and the start of our commercial service, when we take research and private astronauts to space, having successfully completed our thorough flight test program with Unity 25 in May. Virgin Galactic space flights can be carrying our future astronauts for the spaceflight experience or researchers conducting science. This flight will also be the first solely dedicated to research, and Unity is carrying multiple research payloads, which are experiments that are worn by the mission specialists or installed on the rack on board, which will be gathering data and running an array of scientific tests during the spaceflight. Our spaceflight systems can carry both humans and research experiments to space, or both on the same flight. Wherever there is a seat in our spacecraft, it can be removed and replaced with a payload rack. These racks hold payloads that are typically scientific experiments or instruments that will gather data while in space. Today, our cabin has both seats and a payload rack to allow our mission specialists to maximize the research they conduct on board. The Italian Air Force and the National Research Council's mission will include more than a dozen payloads, which will be examining a spectrum of research spanning from the biomedical field, thermofluid dynamics, to the development of innovative and sustainable materials in microgravity conditions, leading to space technology to continue the innovation of human spaceflight in future vehicles and here on Earth. Now, our vehicle system is uniquely positioned to carry out this incredible science, contributing to our curiosity surrounding the cosmos, as well as increasing our understanding of our very own planet. The work done in space gets invested back into the people here on Earth. Now, I could talk about the science all day, but let's first check in with the vehicles and see how we're progressing. JR?
Yeah. Earlier this morning, we saw a perfect takeoff here from our runway at Spaceport America and beginning our mission specialist ascent to release altitude. Mothership Eve is currently continuing that climb with Spaceship Unity on its way to the target launch altitude, which for today is 45,000 feet. In addition to a launch altitude, we'll also be releasing at a designated launch point within the airspace. So while you may see we are already at that launch altitude, we get there rather quickly, we'll continue to complete our flight path until we reach that designated launch point. Everything's looking great. Like I said, we're at 45,000 feet now, and it's just a beautiful view you get from there up there. I can imagine the crew is taking it all in and preparing themselves as we get closer and closer to that big moment. Sirisha, you can provide us with some unique perspective here, having flown on our first Unity crewed test flight. Does this bring back memories?
Oh, absolutely. I mean, when I went to space on Unity 22, one of the crew I went to space with that went with me was Colin. So it's really, really thrilling to see him go back to space a second time. We took moments along the way to soak it all in. The journey of space, I mean, it begins well before takeoff, and actually it lasts well after we'll stop. And seeing all these moments in like the climb where the energy and the anticipation is high, it really contributes to that incredibly holistic experience that Virgin Galactic is bringing to the world. Now, a special shout out for our mothership Eve, a truly unique aircraft designed specifically for these missions. The role that Eve plays in Virgin Galactic space flights is one of the key unique design innovations of our system, and we call it air launch. Most flights you see start with a vertical takeoff from the ground. This requires a huge amount of energy to lift the vehicle from a static start up through the thickest parts of the Earth's atmosphere. Our air launch system allows the spaceship attached to the mothership to take off from a runway like that of a commercial aircraft. This takeoff allows the passengers to have a much smoother and more comfortable ascent as they make their way up to around 45,000 feet. And at that altitude, the Earth's atmosphere is much thinner, requiring less energy to launch. At our designated launch point, our mothership releases the spaceship, the rocket motor ignites, and our crew begin their rapid and exciting ascent towards space. Now, speaking of the crew, let's see who's on board today's flight. Our pilots at Virgin Galactic don't just fly the vehicles, they're deeply embedded in every decision we make surrounding their development. Having our pilots ingrained into every facet of our vehicle operations allows us to get a dual perspective. They work alongside our engineering teams on a daily basis to ensure that we're able to optimize our vehicles' performance, combining the learnings they get from flying them with our knowledge and data on the ground, providing the unique insight that helps us continually progress and enhance our vehicle operation. And today, we have a few familiar faces and, of course, some new ones too. Let's begin with the folks who are supporting today's flight in the chase plane, giving us visuals on the spaceflight system while airborne. In the chase plane, we've got Dan Alix, who has completed over 2,600 hours of flying, logging most of his time in F-16s and F-35s. In Mothership Eve today, we have Jamil Janjua, who's completed over 4,000 flying hours in more than 48 different vehicles throughout his career that spans over 20 years in the Royal Canadian Air Force. Jamil is joined by Kelly Latimer, who has logged more than 6,700 hours in her 32-year flying career.
The crew of the spaceship have a unique structure for CRM, or Crew Resource Management. The left seat pilot is the commander, and the right seater is referred to as the pilot. But the commander and the pilot have specific actions that they perform in the execution of a spaceflight. Crew Resource Management improves safety in operations by emphasizing effective communication, teamwork, and decision-making among the crew members, leading to enhanced situational awareness and the prevention of errors.
So commander of Spaceship Unity today is astronaut Mike Masucci, who recently passed more than 10,000 hours of logged flight in a career that has put him in the cockpit of more than 80 different types of aircraft, including the U-2 and, of course, our very own Spaceship Unity. Mike's family comes from a small town near Avellino in the Naples area of Italy. Piloting Unity today is Nicola Pacile, one of the 5 Italians on board today. He has completed over 6,500 hours in over 150 different types of aircraft. Pacile serves for 20 years in the Italian Air Force, initially as a fighter pilot and later as an experimental test pilot. Nicola was born in Udine in the region of Friuli in northeast Italy. As you can see, our passengers today will be flown into space by some of the most accomplished and experienced pilots in the world. Now, joining our mission specialist in the cabin is our astronaut instructor and fellow Unity 22 crewmate, Colin Bennett. In his role, as this is our first dedicated research mission, he'll be calling out cabin instructions and mission phases while evaluating to continually improve our customers' experience. And of course, joining Colin in the cabin of Spaceship Unity today are incredible 3 mission specialists. First, we have Walter Villadei of the Italian Air Force, commander of the Virtute 1 mission. Colonel Villadei is a space engineer and cosmonaut that will be serving as today's mission lead. His role will be to tend to the rack-mounted payloads during the weightlessness portion of today's flight. He will also be wearing cutting-edge smart suit that will measure his biometric data and his physiological responses. Next up, we have Angelo Landolfi, who is a physician for the Italian Air Force. Lieutenant Colonel Landolfi will be conducting tests that measure cognitive performance in microgravity. He will also be activating syringe payloads from his seat that will investigate how certain liquids and solids mix in microgravity. Our third mission specialist is Pantaleone Carlucci, who is an aerospace engineer and researcher for the National Research Council. Carlucci will be wearing sensors that examine heart rate, brain function, and other human performance metrics in microgravity, and will also be conducting these experiments from his seat. All 3 are contributing to exciting research and technology development with unique experiments. Once cleared to unstrap, 2 mission specialists will likely stay seated to conduct their work, while Walter will be unstrapped, tending to experiments in the back. Now, JR, let's take a break and get an update from our crew who's on Eve and Unity.
Certainly. So, Sarisha, I've just heard from our MCC that the L-10 checks have been accomplished and complete. We are about 8.5 minutes right now away from release.
Now, if you're just joining us, L-10 means we're approximately 10 minutes out from the moment Mothership Eve releases Spaceship Unity, and this is based on the estimated time of arrival to the release point. So again, as JR said, timing may vary a little, but as the closer we get to the release point, the more accurate the estimate becomes.
Yeah. So up until L-10, Eve is in full mothership mode, carrying Spaceship Unity to altitude and providing her with electrical power, system heat, cabin pressurization. And that includes conditioned air cooled on the ground in hot summer days like today and heated at high altitudes to keep our pilots and passengers comfortable. At L-10, Spaceship Unity switches to her own battery power for avionics, that's the electrical systems on board, and control systems, and performs a series of checks, electrical checks, feather system checks, flight control checks, and more. Unity and Eve have their own intercom, so the pilots in each vehicle are coordinating with one another during these checks. You know, what's exciting about Virgin Galactic's spaceflight system is that it's powered by truly innovative tech while it also being a piloted system, being flown by some of the best and most experienced pilots in the world. And that's one of the reasons why we're able to attract the incredible team that we have. They get to pilot a spacecraft that's arguably one of the most unique vehicles in the world.
Thanks, JR. I mean, at Virgin Galactic, we believe in the power of curiosity. It is the driving force that compels us to wonder, to constantly ask questions, and to relentlessly seek the answers. Let's hear from some of the team about how curiosity is propelling the second space age. At Virgin Galactic, we believe in the power of curiosity.
Humans are an adventurous species. It's very natural for us to want to go and explore space.
But we have an opportunity to be at the very birth of routine access to space. It's going to be transformative.
This first commercial flight is a research mission conducted by the Italian Air Force, featuring human researchers and payload experiments.
We're able to further the technologies and the research that end up helping to better human life here on Earth.
Commercial spaceflight is changing what access to space means.
Release, release, release.
Fire, fire.
This is really the beginning of the next space age. All of us have a part to play, and that's going to be the thing that blows the gate open to the next generation.
So inspiring. I can't wait to see where our shared curiosity takes us next. The Italian Air Force and the National Research Council have definitely used their curiosity to fuel their exciting experiments being conducted on board today. They are using the suborbital space lab to the fullest. One of the experiments being conducted on board today is the neuroplasticity experiment. This is a passive experiment consisting of cell culture flasks containing human neural cells in cultures that will fly in a pocket of the researcher's flight suit. The experiment will test the ability to maintain stem cells in culture during suborbital flight and test the early effects of hypergravity, or high G's, and microgravity, or low G's, on neuroplasticity, which is the ability for cells to adapt to their environment. Data from this flight will be used for insight into physiology and pathology, but also be used to investigate biological processes for human spaceflight future missions, and to study and develop new agents for therapeutic purposes for people here on Earth. Now, this is just one of many experiments on board for this mission the crew will be looking after. And speaking of the crew, JR, can we get an update?
Yeah, so we're about 4 minutes out currently at this point, and the pilots are ensuring the spaceship is in the launch configuration after going through the various L-10 checks, confirming that all the settings are go for launch. This is also when Spaceship Unity will isolate the air supply from Eve and prime the rocket motor by opening the backup oxidizer valve. Once these actions are complete, the pilots will seek clearance from the MCC, that's shorthand for the Mission Control Center, for release. So it consists of experts from various disciplines and departments across the company, and they're verifying checks with our crew every step of the way. I don't know about you all, but I can feel the anticipation building just watching the screen. I can only imagine what it would be like to be on board right now. It must be incredibly exciting.
Exciting is definitely an understatement at this point. You're just anticipating the release. I can't imagine what the crew is feeling, and they're anticipating the release and really everything that happens afterwards. So maybe, JR, you could give us a quick overview of the profile?
Yeah, after release, the crew lights the rocket motor, and Unity's trajectory to space begins in that horizontal release position before turning towards space, a maneuver we call the gamma turn. The rest of the rocket motor burn will occur in the vertical, and everything after release through the completion of the rocket motor burn is called boost. Boost is only one of multiple phases of flight that our unique system experiences. After boost is feather. Now, sometimes when we say feather, we mean the tails of the spaceship, and sometimes we're referring to moving these tails into what we call the feathered configuration. It can be confusing, but I'll try to be clear what I mean when I say feathered today. So, due to the law of conservation of momentum, feathering the vehicle, that's rotating the tails to 60 degrees, causes the cabin of Unity to start a backflip maneuver as it approaches our next phase, apogee. And this backflip is a key part of the experience because it maximizes the view of the Earth below. Our pilots use the RCS, that's a reaction control system, to hold the spaceship in that attitude. And then at the right time, the pilots will again use the RCS to continue that backflip all the way around. This prepares the vehicle for re-entry. In the feathered configuration, the vehicle presents a large area of the wing to the atmosphere, allowing our system to burn off energy while still high in the thin atmosphere. And then after re-entry, the feather is once again lowered and locked, turning Unity into a glider. It's in this configuration that the pilots will fly back to Spaceport America in what we refer to as the glide phase. You see, our system is capable of acting like a capsule when that's most beneficial, and acting like a glider when that's most beneficial. Now, MCC's in my ear, they're telling us we're 1 minute away from release. Our next set and our last set of checks before release are L-30, that's 30 seconds to release, and Spaceship Unity pilots will arm the launch pylon, and once we get to that designated launch point, the mothership pilots will engage the release, setting Unity free. Meanwhile, the spaceship pilots will push forward on the stick all the way, preparing for a release. We're now approximately 20 seconds from release. Ten, 5, 3, 2, 1, release, release, release. Ignition. Good control. Trimming, that's pulling the nose up. And trim is set. We're now traveling at approximately Mach 1.4. There's max Q, that's the maximum dynamic pressure on the vehicle. Those on board are experiencing about 3 Gs at the moment. The trim is complete and Unity is in the vertical, headed toward space. Mach 2. Mach 2.8, rocket motor cutoff.
Amazing.
All right. Predicted apogee today is 275,000 feet. That's 84.3 kilometers.
Incredible.
Our mission specialists have been cleared to unstrap and enjoy the zero-G experience.
This is amazing. What you're seeing is Colonel Villaday going to the back to tend to the payloads that are mounted on the rack. You can see Landolfi and Leo starting their experiments in their seat. and having, looks like, a great time, of course.
Yep. The feather is moving, as you can see. Starting that backflip maneuver I spoke of, the feather is now fully up.
Amazing. And viva la Italia! This is 100 years for the Italian Air Force. So happy centennial to the Air Force. This is absolutely incredible. And welcome to space, astronauts. How absolutely incredible. Benvenuto nello spazio. Congratulations to Walter, Angelo, and Leo on becoming astronauts today. And a special congratulations to our pilot, Nicola, for his first space flight. Welcome back to space, Mike and Colin. This is absolutely incredible.
Wonderful.
You can see I'm tripping over my words because I can see all the excitement here. And we've also trained our astronauts as part of our training program to, at apogee, go to the window and take a look outside. So you're seeing them take a look and really reflect and take in the view, because all of the science and all of the research that they're conducting on board is for that vehicle, for that planet that they're looking out on. It's really that science and research being invested back into this planet, and it's important for them to reflect and see where their hard work is going.
Right. We have achieved apogee at 85.1 kilometers, or 279,000 feet.
Incredible.
The pilots are currently completing the backflip maneuver, orienting the vehicle for re-entry. Now, just before 0.1 Gs, the pilots will give that return to seats call to the mission specialists. And our training team has worked this portion of the flight out so that it's very natural and intuitive for our passengers. You know, when we talk about space travel, a lot of people know and they expect the boost portion of flight to be loud and thrilling, and of course it is. But what's interesting is that the re-entry is actually very similar. So as supersonic air flowing over our vehicle in the feathered configuration, shock waves form on top of the cabin, and those are audible to those inside. And for those of you on site here at Spaceport America watching from the ground, you should hear a double sonic boom as Spaceship Unity once again breaks the sound barrier. We're currently at Mach 2.5.
Incredible.
And just back to 1G as we begin re-entry.
And those views are just absolutely amazing.
Yes. So for re-entry, we're now at about 3.6 Gs for those on board. The crew will orient the attitude of the spaceship so that when we come out of re-entry and feather down, we'll be pointed toward spaceport. We're now subsonic and at 75,000 feet.
And the unique part of our design is as a vehicle that can get into this feathered configuration. We're a glider, we're a rocket, we're a glider, and we're a capsule at the right phases of flight that help our unique design be safe and effective for the mission it's at.
That's right. We're at 61,000 feet now, continuing to descend in the feathered configuration. When we get down to about 53,000 feet, the pilots will command lower of the feather again and reconfigure the vehicle back into a glider.
The views are just so incredibly amazing all the way down, and it's just part of each phase of flight has its unique experience. It has the ability to also conduct science. Our payloads that are on the rack are conducting and recording data all the way through each phase of flight. So you get hypergravity and low gravity data and that transition in between.
The feather is almost completed. The feather down. It is now down and locked.
Those watching from Spaceport America, now's a great time to go outside. Unity will be coming into view, and you can cheer on the crew as they return to Earth. Now, the mission specialists on the flight are supported by an incredible team on the ground from both the Air Force and the Center for National Research in Italy, who designed and developed the research being conducted on board. Space-based research is an incredible capability that is being opened up by suborbital vehicles like our own spaceflight system. One of the researchers utilizing this capability to the fullest is here with us in the studio. I'm so excited. A future astronaut, a friend, and a space-based researcher, Kelly Girardi. Welcome to the studio.
Thank you. I'm so excited to be here. Thanks for having me.
Okay, I gotta ask, how are you feeling having watched this incredible crew go to space today, knowing that you're gonna be there on a future space flight?
It's surreal, I have to say. Just the energy outside, and I've had the benefit from being on this side of the live stream for a number of Virgin Galactic space flights, including yours, and it's so special to experience that here at Spaceport America with the crew and their families and the Virgin Galactic workforce and mission control. And it's emotional. I remember during your space flight when I heard release, 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 I burst into tears, and I'm glad that my mic was off during the live cast, but it's the profundity of human spaceflight, and I'm so ready to be on the other side of this live stream.
It's incredible. I mean, this is my 6th space flight, and you probably saw I was tripping over my words. I just couldn't get it out because of the excitement.
Exactly.
And so you're on a future dedicated research mission. Could you tell us a little bit about the science that you're going to be conducting?
Yeah, absolutely. So I'm flying on a dedicated research mission. I'm representing my research institute, the International Institute for Astronautical Sciences, and I'm going to be doing healthcare and fluid research in space. I'll be wearing a wearable sensor system to take biometric monitoring. It's called the Astroskin. It's currently worn by astronauts on the International Space Station, but my flight will be the first time we're collecting data during the launch, re-entry, and landing phases of flight as well. And then fluid research. To help design, I'm going to be looking at how fluid behaves in a container in microgravity during flight, and that can help inform new designs for life support systems or syringe design for administering medication in space, things like that. So I'm very excited.
I can't wait.
Me too.
I cannot wait. So what role do you see suborbital vehicles like VSS Unity playing in future research?
Yeah, it's critical. I mean, this is a new era of access to space, and there is a tidal wave of scientific research that can benefit from this platform. You know, we've done a lot of work, a decade of work here on Earth, iterating with payloads, payload operations, technology iteration, international collaboration, parabolic flight campaigns where the aircraft takes that roller coaster profile here on Earth, where you get short bursts of microgravity. That's amazing for quickly iterating on technology, but to really validate it, you need high-quality microgravity, and you need longer duration exposure to microgravity. You need to be in space. And so I'm really looking forward to the availability of Virgin Galactic as a platform, not just for the scientific community, but for academia, for students, for so many. So I'm so excited to get to be a part of that.
Yeah, absolutely. So I know you did not plant this question. Everyone watching should not plant this question, but Kelly, I loved your book, not necessarily rocket science.
I did not plant that question.
But part of the appeal of suborbital vehicles is really opening up the aperture of who can do science and technology. And this is just another science lab for people to utilize to further whatever field of research that they're in. Can you talk about some of the other research fields that are utilizing these kinds of capabilities, maybe even at IAS?
Yeah, absolutely. It's really multidisciplinary. It's not just space science. My colleagues come from such a wide variety of backgrounds and fields of research. I've been particularly motivated by some of my colleagues who are doing research related in space, related to the quality of human life here on Earth, human health and well-being, whether that's biomedical or pharmaceutical research, or even new ways to approach telemedicine or, technical instruction for remote or extreme environments. I just think those are use cases that are so compelling and interesting to me to really use space to benefit life here on Earth.
It's absolutely amazing. And I love how you speak about this industry because you've been an advocate and a part of this industry for a while. And can you talk about what drew you to the commercial space side?
Yeah, absolutely. I have long been an evangelist for the commercial spaceflight industry, and I've really been inspired by it. I have a deeply rooted belief in the potential of this industry to open up access to space, to truly democratize access to space, certainly for science communities and for the research community like myself and the crew of Galactic 01. But also for civilians of all disciplines. I really do believe that the space age is a broader cultural movement, and that our next giant leap will require the talents of artists, engineers, and everyone in between. Space is our shared past and our shared future, and that's why I wrote not necessarily rocket science.
Okay, well, we're going to be getting to landing soon, but I wanted to ask if you had any parting thoughts before I release you to go cheer on the crew as they return to Earth.
Yeah, just awe excitement. I'm sure you can tell. I'm just, it's amazing to be here. And just deep appreciation for all that goes into this and all that this means. I know this is the beginning of routine and regular commercial operations, but to me, it will never get old.
Oh my God, thank you so much for
Thank
joining
you.
us here
I'm going to run down and welcome that crew back.
Thank you,
Thanks.
Kelly. All right, this is just an absolutely exciting time for the research community. I mean, the excitement off of Kelly is just palpable, and I can't wait for us to be cheering her on as she does her research in science and space soon. So let's check in with our crew on their descent back to Earth.
Absolutely. So we are just over 11,000 feet. For those of you here on site, Unity just crossed over the field and is making another circle around in the pattern. Beginning those landing approach, passing the waypoints that we've designated as part of our energy management plan. So the pilots have joined up with Chase in the pattern, and they're discussing that energy management plan. They're going to be landing today on runway 34. That means from south to north. And for those non-pilots tuning in, those numbers represent the first two numbers on a magnetic heading of the compass for the runway direction. So for example, 34 is 340 degrees. The landing gear is now down and locked. We have 3 green. That means all gear are down and locked. And we're making our final approach to the runway here at Spaceport America. We like to make left-hand turns for our approach. That's because the commander is in the left seat, and that provides the best line of sight for them as they come into the landing. Now, the runway here at Spaceport America is 12,000 feet long. That's 3.7 kilometers and 200 feet wide, or 61 meters. 1,000 feet above the runway. 500 feet. Over the threshold, that's the beginning of the runway. And you'll see the pilots hold the nose up. That's a flare maneuver, all part of the energy management. Main gear touchdown. So the pilots will continue to hold the nose gear in the air as we continue to bleed off some energy as we run down the runway. And at the designated airspeeds, they will lower the nose gear as well. Nose gears down. Now, as our ground speed slows, when we reach a designated ground speed, the pilots will apply the brakes and bring the vehicle to a complete stop. All right, braking now. And there's wheel stop.
Oh my goodness. What a beautiful landing and a perfect way to complete our first commercial flight and our first dedicated science mission. Congratulations to everyone on board, our very own spaceship Unity, who returned to space today. We saw beautiful flying from our Eve crew, Jamil and Kelly, and brilliant work by our chase pilot, Dan Alex, all of whom are still in the air right now. Great job to you all. Now, we still have one more guest here in the studio with us, Italian Air Force Major General Maurizio Cantiello, who's the Defense Cooperation Attaché at the Embassy of Italy in Washington, D.C. Benvenuto, General. Thank you for being here.
Thanks for hosting.
Well, I just have to ask you, how are you feeling today after seeing that?
Well, it's a strong joy, a deep joy, and also a sense of achievement and gratitude for everybody making it happen. And, you know, it's a particularly important moment for the Italian Air Force. With this flight, together with other things we're doing, we're progressing a lot into space capabilities because it's very important for the Italian Air Force to be able to progress in competence and capabilities in the space domain as a key enabler of the space economy. which is very important for Italy as well. This flight was particularly important also for not only for the experiments that were very important and very different, and several experiments, but also because we are studying other ways for space access, not just vertical access, but horizontal access. And that could provide different forms of space access. And as you know, our mission is to protect and defend. So by law, Italian Air Force is responsible to defend the skies of Italy. To defend the skies, it's a very important mission. And to be able to do it, we must know well, because you cannot protect what you don't know. So for us, increasing our knowledge and our competence in this field is paramount for the defense of Italy. So we are grateful to Virgin Galactic for having us here and giving us this possibility to work together. We are grateful, of course, to the Italian National Research Council, where we work together for the experiment. And of course, we are grateful to our nations, Italy, to invest in this very important endeavor, and to this great host nation, the United States. We are very, very, very good partners and allies. So everything happening here has a profound significance for the bond, and the ties between the United States and Italy as well.
That's absolutely incredible. Is there anything you want to say to the crew, to the teams on the ground, and also to just the people in Italy watching from their homes, cheering everybody on?
Absolutely. I would like to express a deep gratitude, first of all, to God, to make it all happen. And, I was a little bit concerned, not for safety, but for the health of my friends, because they were all good friends. Not just the pilots, but the crew as well. So thanks for that. And also thanks to Virgin, thanks to the pilots, thanks to the team, the ground team, thanks to the specialists, and also, of course, thanks to our institution, our governmental institution. Because today we saw something which is very important. I call it like a sweet spot when you see commercial world, industry world, and then academia and the government institution. So it is very important when we work, these three areas works together. And when academia, the government, and the commercial world work in harmony and in unity, like today, miracle happens. And space too.
Absolutely. Now, I know you're going to be out there ready to greet the mission specialists as they come out of the spaceship, so I don't want to keep you, but, happy centennial to the Air Force. You've had 100 years, and there's going to be 100 more, many of them hopefully spent in space. Yes. Thank you for joining us in the studio today. Thank you.
Bye. Thank you.
Incredible. Thank you to everyone on the ground here at Spaceport America who made this day possible. We cannot wait to hear about the experience from our mission specialists and to see the results of the experiments conducted on board. We will be continuing the celebration here as we await the arrival of all the other vehicles. Wherever you are on planet Earth, we thank you for watching. We'd love for you to join one of our upcoming future missions. Please join in on the celebration via social or head over to our website to learn more about this mission and how you can embark on your own journey to space. Ciao. Ciao.
This concludes the mission of Galactic 1 at Spaceport America. Thank you for joining our broadcast. For more information how you can fly with us, please visit virgingalactic.com. See you next time.